Today we will see about the next chapter in vector spaces, that is orthogonality. So here, if we have means in the orthogonality, so we have we will start with the inner product. Okay, the inner product of the vectors. Okay, so here if u and v are vectors in Rn, means Rn is the real field, the real MS field. If u and v are the vectors, then we consider u and v as a n cross n matrices. Okay, so n cross n matrices means n is number of rows and 1 is column. Okay, means this is like as we mentioned, so v1 v2 vn. So here the number of rows, so n rows and 1 column. Okay, so if u and v vectors, if we represent, means the vectors represent like this, we will consider like this. Okay, so then u transpose matrix, okay, means if u is the vector like this as we mentioned here, u1 to un, okay, then u transpose, then we can give as a means the one row and n columns. Okay, so one row n columns means if the v is like this, then the v transpose will be like this. So n columns and one row. Okay, that we call as a, that is 1 cross n here. Then the matrix product by that one means the matrix product by u transpose into v. Okay, u transpose into v, then it is 1:1 matrix. Okay, so after the transpose, the whatever the multiplication we are doing with other vector, so that we are calling as a, means that is a size of 1:1 matrix. So that product u transpose into v is called the inner product of u and v. So inner product of u and v. So here, so as we means now we will see with the examples. So here it is written as, means if u is a vector, okay, so u is a vector of n cross 1, if you do transpose it will be 1 cross n, and one more the v vector will be there. The product of that if we did, we call as inner product of u and v. So that we can represent, so here that is u dot v. So while writing the inner product we can call as a u dot v, but actually it will be u transpose v. Okay, so u transpose v means it is like, if in general if u is a matrix like this and v is a, means if u is a vector like this and v is a vector like this, the inner product of u and v, that is u dot v, is nothing but u transpose v. There is no dot here, u transpose v. So u will become, means u transpose will become like this. So v is like this, then the product will be u1 vn, u1 v1 plus u2 v2 plus u3 v3. So like that it will go on, then plus un vn. Okay, so this is how the inner products will look like. Okay, so then we'll see some example here. So compute u dot v and u v dot u. Okay, so if u and v are like this. Okay, so u dot v is nothing but, as I told, u transpose v. So u is 2 minus 1, sorry, minus 5 minus 1, so it will become u transpose 2 minus 1, 2 minus 5 minus 1, and uv is as it is. So if you multiply u dot v, so it will become 2 cross 3, means 2 into 3 plus minus 5 into 2, then plus minus 1 into minus 3, so it will become minus 1. Similarly, if you do v cross, sorry, v dot u, then it will be, we need to take v transpose, then multiply with the u, then it will be, means same. So then we say that, okay, so v dot u is equal to u dot v. Okay, both are same. Okay, the same thing, just we are giving some notations, means just some laws we are representing here. That is u dot v is equal to v dot u, then u plus v. Okay, u plus v dot w is equal to u dot w. Okay, means u plus v into w is equal to u dot w plus v dot w. Similarly, the c is a scalar here. Okay, c u into v is equal to, that is u dot into cv. Similarly, u dot u is always greater than or equal to 0. Okay, so if it is 0, then if and only if u is 0. So this will become 0 only when if u is 0. Okay, so this is we call as means the inner product of u and v, and which the size of 1 cross n. Okay, and the product always will be the 1 cross 1, means only one value you will get. Okay, the next one, then if you have the vector, okay, how to find out the length of that? Okay, so we have in the field, you'll having many vectors like v1 v2 v3 up to vn. Okay, how to find out the length of that? Okay, so always we need to remember v dot v is non-negative or positive. Okay, means the inner product of same vector v dot v or u dot u or w dot w, so always it will be positive, that is nothing but the non-negative. Okay, so now the length of the vector, okay, if it is a vector like this, okay, so length of the vector we can calculate by suppose v is a vector, then length of the vector we are representing with a, that is magnitude. Okay, like magnitude. Okay, so then it is given by length of the vector is nothing but the root of v dot v. Okay, root of the inner product of the same vector within a square root. Okay, square root of that is nothing but v1 square plus v2 square plus v3 square plus like that vn square. Okay, this we need to keep in mind. So length of the vector or magnitude of the vector is, okay, so what are the number of elements in vector? Okay, what are the elements in number of vector? So square of the means addition of square of that, and after that the square root of. Okay, then v square, obviously the magnitude square is equal to v dot v. So if you take an example, means if v is a vector ab, okay, or we can represent like this, then length of the vector is v double bar is equal to, that is square root of v dot v. Okay, v dot v, how to calculate v dot v? So v dot v is nothing but v transpose v, so that is nothing but ab multiply with ab, then it will be a into a square plus b into b square, so it is a square plus b square. Then what is magnitude? So that is square root of v dot v. So if you do the square root, then it will be square root of a square plus b square, so which matching with the general form here. Okay, then after knowing the length of the vector, then what is a unit vector? So unit vector means unit vector is a vector whose length is 1. Okay, suppose you have any vector like u or v or w, whatever it is, so which the length of the vector is 1, then we call as a unit vector. Okay, then we call as unit vector. Then how to calculate that one? Okay, means how to calculate the, what is it, how we say that the unit vector. Okay, so now if we divide, means u is equal to, sorry, normalized vector of u, yeah. So now how to say that that is vector is a unit vector? So that I told, if the length of that is 1, then we call as a unit vector. But one more thing, we call as the normalization of the vector. Okay, normalization of the vector means suppose the whatever vector is there, if it is divided by its length, okay, the vector is divided by its length, or we can say that the vector is multiplication by, okay, 1 by length of that, 1 by length of that, so then we call as a normalized vector of v. Okay, that is the same thing, if you divide non-zero vector v by its length, we get the unit vector we call as a u. Okay, so how to find out the unit vector of the some vector, given vector, how to find out unit vector? Then that vector divided by length of that. Okay, so this is how to find out unit vector, and this is how to find out length of the vector. Okay, now we will see the examples. Okay, so in this example, first one, we are considering the vector v 1 comma minus 2 2 and 0, find the unit factor in the, okay, we need to find out unit factor. So how to find out the unit factor? So v is given, okay, so what is, how to find out unit factor? V divided by length of that. Okay, so find out the length, square root of v dot v. So that is nothing but how many elements are there? 4 elements. So 1 square, 2 square, so minus 2 square, 2 square plus 0 square, so it will become 3. Okay, it is nothing but, so v write as it is and divided by 1 by 3, so then it will become 1 by 3, 2 by 3, minus 2 by 3, 2 by 3 and 0. So this we call as unit factor. But how to prove that one? We have calculated the unit factor, but how to prove that? Means if the unit factor length is 1. So here in the previous we have seen the unit factor we will call when it is length of the, that is 1. But how to calculate the unit factor? That is v by, okay, means v by length of that. So here if you got u now, if you find out the length of that and if it is a 1, then we call as u as a unit factor. Okay, similarly you take the other example. Okay, u is a vector and v is a vector, u minus v. Okay, straight away it is u minus v, 7 minus 3 4 and 1 minus 2 minus 1. Okay, the length of that will be, so what are the elements are there? Okay, so u minus v elements are 4 minus 1, so square of that, it is a length of u minus v. Okay, the similarly we will take means some other problem, means, okay, so if distance, okay, if for u and v in Rn, the distance between u and v written as a distance of u comma v is the length of vector u minus v, means the length of one vector and minus length of other factor, so that we call as a distance between u and v. Okay, so as I mentioned, so then after seeing the length of that and unit factor, so what are the orthogonal factors? So we say that orthogonal factors, orthogonal factor when is, if the dot matrix, okay, if the inner product, whatever the vectors we are calling as orthogonal, so that inner product is 0, means if there are two vectors like u and v, so u dot v is equal to 0. So as we have seen here, okay, u dot v is 0, then we call as a orthogonal. Okay, so two vectors u and v are orthogonal if and only if, okay, so that is u plus v whole square is square. There is this is one more okay, the law means law in the sense, so we can prove that u plus v whole square is equal to u square plus v square. Okay, but we call as orthogonal when their product is 0. Okay, then what are the orthogonal components? Okay, so these, what you have seen is orthogonal vectors, but orthogonal complements, sorry, not components, orthogonal complements. Okay, so if vector z is orthogonal to every vector in the subspace W of Rn, means if there is a vector z and it is, we say that orthogonal to vector in a subspace, okay, to every vector in a subspace. What is subspace? So it is a subset of the main vector space. Okay, in that, in subspace, what are the vectors are there? For that, if any one of the vector z is orthogonal, then we say that z is orthogonal to W, means subspace. Means if there is v1 v2 v3 in the subspace, if, okay, so v1 is orthogonal to each one, orthogonal to v2 and orthogonal to v3, then we say that v1 is orthogonal to W, that is subspace. Okay, so similarly, so let A be an m cross n matrix, then row space of A, okay, row space of A transpose is equal to null of A, and similarly the column space of A, the transpose is equal to null A transpose. Okay, these means in this case the row space of A is orthogonal complement to the null A. Similarly, the column space of A is orthogonal complement of null A transpose. Okay, so this can be represent like this, means if any vector is orthogonal complement to the subspace then we can give that z is equal to w, sorry this is not t, w perpendicular. Okay, so this is orthogonal complements, and this is orthogonal factor u dot v. Then how to find out the angle between the vectors? Okay, if there are the vectors like this, how to find out the angle? So this angle we can find out. Okay, so one is u and one more is v vector, then it will be cos theta is equal to u dot v, that is inner product, divided by the length of each vector. So length of u cross means sorry into the length of v. So by using this equation, cos theta is equal to u dot v and divided by length of each vectors multiplication, we can find out the angle between the vectors. Then what are orthogonal sets? Okay, orthogonal sets. So we have seen orthogonal vectors, but here the set of factors. Okay, you can see here a set of factors u1 to up in Rn is said to be orthogonal set if each pair of distinct vectors is orthogonal. That is ui dot uj is equal to 0 whenever I is not equal to j. Means if, as mentioned here, if there are u1 u2 like un vectors, then any pair in the sense, so here for example u1 dot u3 or u5 dot u8, so any pair, the dot product it should be 0. If any pair dot product is 0, then we say that the whole set is orthogonal set, means set of factors. Okay, similarly here we can say take the problem, there are three vectors u1 u2 u3. Okay, so we need to say that the set of u1 u2 u3, is it the orthogonal set? So we say that orthogonal. Then what are the possible things of pair? If there are three vectors u1 u2, okay, u1 u2, then u2 u3, then u1 dot u3. Okay, these are the three possible combinations of pairs. So these things we need to calculate. u1 dot u2, how to calculate? u1 dot u2 is equal to u1 transpose u2. So this is u1 transpose multiplication with u2. So by multiplying straightforward, means it is coming 0, means it is multiplying means the first digit with first digit, 3 into minus 1 plus 1 into 2 plus 1 into 1, so that is becoming 0. Similarly u2 dot u3 also coming 0. Similarly u1 dot u3 also coming 0. Okay, so if all possible pairs are coming 0, then we say that the set is a orthogonal set here. Okay, so similarly we can take some important terms here. Okay, if the set u1 up is orthogonal set of non-zero vectors in Rn, then S is linearly independent, hence is a basis for subspace spanned by S. Means what it means is, if there are factors, the set of factors, if they are orthogonal set, means after calculating the pair of dot products, if it is coming 0, then this S is nothing but that is a linearly independent. Okay, similarly the orthogonal basis for a subspace W of Rn is a basis of that and also orthogonal set, means it is similarly the same thing in a different way. So if it is, means it is a orthogonal, if it is orthogonal set, then we say that that factor set is the basis for subspace. Okay, similarly if let u1 u2 up be the orthogonal basis for the subspace W of Rn field, for each y in W, the weights, the linear combination. Okay, it's like the linear combination, how we can give is c1 u1 c2 u2 like that, cp up, where u1 u2 u2 are vectors and c1 c2 are the weights here. Okay, so that weights we can calculate. So how to calculate the weights is, that is cc is equal to, so j is varying from 1 to p, so that is y, means this one, so y into uj, any vector divided by means the product, inner product of y into uj divided by uj into uj. So by calculating this we will get the weights with respect to j1 j2. Okay, so now we'll take one example. There is a set S u1 u2 u3 orthogonal basis for R3, means number of elements in vector. Then express the vector y as linear combination of the vectors, these three vectors. Means he has given as y, okay, he has given as y, and he has also given u1 u2 u3, and we need to show the y is a linear combination. So how we can show y is a linear combination? So we need to show that this is orthogonal set. Okay, so here what we need to do is, means if this equation is satisfied, then we call as a the linear combination. Okay, so here we need to compute y is equal to c1 u1 c2 u2 and c3 u3. So we know that u1 u2 u3, we know that y. Then how to calculate c? So c is nothing but y dot uj divided by uj into uj. So that is nothing but, so now here y dot u1 is equal to, first, okay, first you calculate, so y dot u1, means to calculate c we need to calculate y dot u is nothing but u1 now. So y dot u1 is equal to y transpose u1, then if you multiply here it is coming 11. Similarly y dot u2, so as there are three products are there, three vectors, y dot u2, that is y transpose u2, so that is coming minus 12. Okay, similarly the next one, so that is y dot u3, okay, it is coming minus 33. Then u1 dot un, okay, so equation you can give it here. So y is equal to y dot u1 divided by u1 dot u1 plus y dot u2 divided by u2 dot u2 plus y dot u3 divided by u3 dot u3. Okay, so here into u1, so we know that is we need to calculate c here. So y dot u1 we have calculated, u dot u1 we have calculated, just we need to replace. So then we show that that is a linear combination, that is y is equal to u1 minus u2 and minus u3. So similarly so orthogonal projection, so let u be the vector in Rn. Okay, so consider the problem of decomposing a vector I y in Rn into sum of the two vectors. Okay, sum of two vectors, so one is multiple of u and other orthogonal to u. So we can write it as, means, so basically here we are looking into projection. So how to look into the projection is, so y, if there is a vector, okay, y, so the y projection on u, okay, so y projection on u, if this u is a vector here, y is vector, y projection on u is nothing but, you can take the horizontal, means perpendicular line here, perpendicular line. So then, okay, if we want to calculate y projection on u, then we need to calculate, so y bar is equal to alpha u. Okay, so this is alpha, sorry, u value. Then z, so here this value is nothing but z is equal to y minus y bar. Okay, so this we can show, this we can show as, so as we say, means the projection of y on u. Okay, so we can term into two products, means two parts here. So one is y bar, one more is z. So y bar is nothing but, that is orthogonal to u. Okay, so one more is the sum of sum of two vectors here. Okay, so one is multiple of u. Okay, so one is multiple of u, that is y bar. One more is orthogonal to u, so orthogonal to u is, that is z. Okay, so one is multiplied by u and one more is orthogonal to u, that is y minus y bar. Okay, y minus y cap here. Okay, so that if it is like this, then we call as z is perpendicular to, means here, so sorry, as z is perpendicular to u, as we see here z is perpendicular to u, so z dot u is equal to 0, means we say that orthogonal when the two inner product is 0, so z dot u is equal to 0. Then what is z? Y minus y bar, y minus y bar, y cap, so into u, so what is y cap? So y cap is equal to alpha u. Okay, then it will be y dot u minus alpha u dot u, so then alpha into u dot u is equal to y dot u. So then alpha is equal to u dot u divided by u dot u. Okay, then y cap is equal to alpha dot u, then okay, you replace alpha, so y dot u divided by u dot u into u. So in general we can give as the y, means we can give as y cap. Okay, so here the vector y cap is called as orthogonal projection of y onto u. Okay, and the z is component of y orthogonal to, the z is component of y orthogonal to u. Okay, so here the projection y cap is calculated by like this, y dot u divided by u dot u into u, but in that case means z we call as the component of y orthogonal to u. Okay, so this is how to calculate the projection of one vector on the other vector. Okay, you'll see the problems on that. Okay, so here we have two vectors, the y and u. Find the orthogonal projection of y on u. Okay, so it's one is to calculate the projection of y on u, and other is then write y as sum of two orthogonal vectors. Okay, that is as I told, so one is summation and one more is multiplication of alpha with u. Okay, so here to calculate the projection, what is the projection equation? Y cap is equal to y dot u divided by u dot u into u. So here first we need to calculate the first term y dot u, that is straightforward, that is 28 plus 12. Okay, product of this plus product of this, or we can calculate y dot u is equal to y transpose u. Okay, so that also we can write. So that is y dot u is equal to 40, u dot u is equal to 20. The projection of that will be y cap is equal to y dot u divided by u dot u into u. So we have calculated both the terms, then multiply with u, that is u is 42, it will become 84. Then after calculating the projection, we need to calculate orthogonal component. Orthogonal component means that is z. Okay, so z is equal to y minus y cap. So y is this one, already we know, y cap is 84, so it will become minus 1 2. Okay, so here then other component is, okay, so that is y is equal to, means the two components we need to, so here what we did is z we have calculated. Okay, so here y is nothing but, sorry, y is equal to y cap plus z, so y cap plus z is nothing but y minus y cap. So here we know what is y cap, we know what is y minus y cap, just the previously we have calculated, then we know that what is a y here. Okay, means the sum of the two components, the y cap and z. Then we need to say z, whether we need to check whether z is orthogonal to u or not. So z dot u, so z dot u is z we have calculated and u is here, so both you multiply, it is coming 0. So we say that z is perpendicular to u. Okay, so this is regarding the length of the vector and projection. Means we have seen the projection of y on u. Okay, and to calculate the two components, okay, that is z and also the z dot u, whether is it perpendicular or not, both are. Okay, and we have seen ortho means the concept of orthogonal projection and what are orthogonal set. Okay, so that is multiplication of the pair of factors. If it is coming 0, we call as orthogonal set. Then what are orthogonal vectors? Okay, how to find out the length of the vector? Okay, and what is inner product? Okay, so this is with respect to these all things. So in the next class we will see about orthonormal sets. Okay.